what we have done yesterday. We stop at the fiber connection. Okay. Right now we need to understand new concept. It's sending data in Ethernet.
Hey guys, good evening. Hello, am I audible? Okay, great. So let's start for the day today. So just a brief introduction about what we did so far. We are not going to run through the slides because it will take a lot of time otherwise. I'll just tell it verbally. We have understood the blueprint of the CISCO 200-301. Okay, the course is related to CCNA 200-301 and there's a combo pack with it that you're going to learn CISCO ASA Firewall. Okay, so just let me share the blueprint once. So this is the blueprint of CCNA 200-301 exam. As of now, we have not started very precisely with CCNA because we are just having a basic platform. I'm trying to create a kind of interest among you all so that you get to know what is networking. After you enroll for the course, that is, since we have the class free today and tomorrow, from Monday, we will be starting with full-fledged according to the blueprint. So I will be highlighting each and everything as we do. As we finish each and every topic, I will be highlighting that this is what we have done. This is what the lab is about, and this is the quiz about. So as you are already aware, since last 2 days, we are also conducting quizzes. So this will be a part of your course every day. So every day, whatever you learn, maybe the last class or maybe to the ongoing class, you're always going to attempt a quiz based on that. So based on this blueprint, full-fledged right from each and every topic. Let's say the first topic is related to the functions of network components. So today we are also going to discuss the networking devices in short. I'm going to cover a few of the devices like routers and switches, what are their roles and functionalities. Access points, controllers, servers. Today I'm not going to talk about that, but I'll be talking about the routers and the switches because they form a very important device in your networking architecture. Then we will be discussing about architecture, not today, but yes, from Monday onwards, as soon as we start full-fledged, I will be highlighting each and every topic what we cover from this blueprint. So the first topic is related to the fundamentals. We have already covered the OSI model. We have understood what are the different layers in the OSI model. We also understood that that OSI is just a reference model, and we normally use TCP/IP protocol suite in the real-time scenario over an internet. So the second topic is related to the network access, where we'll be talking about the VLAN, the different types of VLAN, the trunking ports, and how to configure Ether channel. So this is related to the network access. This is again fundamental. Those who are interested with security and all, they should have a good knowledge about this switch, because the first point of attack which comes is firstly is the switch, that is a layer 2 device. Then comes the third module, which is IP connectivity, where we'll learn about the different IP routing protocols, what is the meaning of the different parameters like AD, that is administrative distance, the routing protocol metric for RIP, for OSPF, for EIGRP, for VGP. Then we'll also see what is IPv4 and v6 static routing. So this is related to the IP connectivity. So, and then the later fourth module, we have the IP services, DHCP, NAT, PAT, FTP, SNMP, all management related services, protocols that will be related to IP. And the second last module is related to the security, where we will be learning VPN, access list, and DHCP snooping, ARP inspection, ARP poisoning. So all related to security fundamentals here will be covered. Okay, so once we have an idea about how does a switch work, how does a router work, what is an IP address, then we can dive into the security fundamentals. And the last one is automation and programmability. Now this module is more or less very theoretical, though we'll try to see something. I'll show you in practical scenario, but this will not be covered in very detail as we do it in our other courses like network automation using Python and Sybil. Okay, there we have a full-fledged course where we have a lot of scripts, maybe more than 75 scripts we have, where we demonstrate how to push a script to the real-time switch or a router. But we'll have some understanding about software defined networking over here. How does the traditional networking has been shifted towards the software defined networking? So instead of having multiple of brains, we have a single brain now. Likewise, that is somewhat I can say in just a few sentences. So there you will learn about automation and programmability. That is a need of the day now, to understand how to automate the processes what we were doing before, manually sitting in front of the PC and pushing up the configurations. So this job is now very simple. Once you understand the basic fundamentals, then it will be easy for you to shift towards the automation and programmability. So this is the blueprint which we will be following when we are going to start full-fledged from Monday. For those who have already enrolled and those who are yet to enroll, please enroll it faster. Since we have limited seats, we have not kept a very big size batch. It's a very small size, so that everyone, we can cater to all of your doubts. And plus we have a remote lab access server, which I had already discussed, that once you enroll the course, you get all the recordings available in our web portal. You get remote access to the lab server, free 4 months access. You get to know the different other softwares, how we install. Okay, plus ASA firewall, already that course is already included with CCNA. So I guess this is a good offer for you all for the new year. So I hope we are set for the day today. Now today we'll be talking something more interesting related to the devices and some types of communication yesterday, which I started. Okay, yesterday when we were discussing about ARP, yeah, to access the lab, we'll give you all the instructions once we start full-fledged from Monday. Starting today is with the new topic that is related to the communication types. So today I'll take up a very light one, since I could understand that maybe yesterday the topic was a bit on moderately. I can say moderately it was a bit difficult because did not start with any of the networking devices before. But all these 5 days I'm just covering few elements from each of the section of this Cisco CCNA200-301 exam. So we are picking up few of the topics and I'm explaining you those topics there. But again, from the scratch, we are going to start from Monday, following the blueprint. So today we are going to understand what are the different types of communication. Okay, so we know that there are 3 types of communication broadly. They are unicast, multicast, and broadcast. All right. So unicast means if I have to send data to an individual PC or to an individual Mac. Okay. And when I'm talking one-on-one, I say that we are having a unicast communication. Yesterday, when you saw that the ARP packet tracer file, when I showed you how the broadcast goes, and then the PC which receives the packet, with the intended recipient only accepts the packet and then it replies. So the reply which was given was a unicast. It was not a broadcast. So unicast means if you are sending the data to an individual PC or an IP or a Mac, whatever we say. Multicast is when I am sending to a group of PCs or a group of people, I can say. When I'm talking to you all, you are a group of people whom I am talking or I'm interacting with. So we are having a multicast communication. And a broadcast can be, I can say multicast is a subset of a broadcast. So broadcast is where we just try to give it the information to everyone. So whenever we have an information, we say we broadcast it. So the information which is meant for all is a broadcast communication. So when does a computer understands that it has to accept this particular packet or a frame? If it is meant for its own, then it has to obviously accept the packet. As soon as it receives the frame or the signal from the physical layer, we will be starting from the bottom layer, layer 1. It looks into the physical specification. So the data comes up and then it goes to the next data link layer where it encapsulates, where it decapsulates that who is the source MAC, who is the destination MAC. Then if it sees that, okay, this was a broadcast, so let me accept it. Again, then it checks whether the source IP and the destination IP, whether it is meant for me or no. So the computer accepts the frame or packet when it is meant for its own, if it belongs to a specific group, or when it has come like a broadcast. So these are the three communication types. Okay, this is very, very important to understand because more or less we are going to use these terms or terminologies ahead in our future lectures, that what do we understand by unicast, what do we understand by multicast and broadcast. Coming down to this is how we can just check out the through this, that we have a unicast. So if it is a unicast message, so PCA to PCC, only the intended receiver will accept the packet. A multicast where all the group of people, say PCD, PCC and D are belonging to the same group, and broadcast where each and every PC is accepting the frame or the packet. So these are the three types of communication or transmission, I can say. Next, we'll move on towards the topology. This is the way you are trying to arrange your systems, your computers, your servers. So based on this, we say that topology is just an arrangement of the networking devices, the way we arrange the device. So we have a bus topology, we have a ring topology, we have a star topology, hierarchical topology, and a mesh topology. We also have a hybrid one where we can use both bus or a ring, or we can have a bus and a star kind of a topology. So this is very important to understand how we can have an arrangement of different systems in order to have a better communication. So which one should we use, for which application we should use, that I have discussed in my forthcoming slides. Starting with the mesh topology, as you can see from the diagram, here there's a kind of a web-like structure where each and every computer has a connection with all of the computers in the same network. Okay, so every device has a point-to-point link to every other device. So if node 1 has to be connected with n-1 nodes, you see that this kind of topology will be understood as a mesh topology. Now, coming back to what are the advantages and disadvantages of this topology, it is very evident from the diagram and from the fact that it will require a lot of cables, and also the troubleshooting would be very difficult into it, because you see the kind of connections which are made from one point to the other point. This topology will be required where you find that the redundancy is very much important. Wherever you feel that there should be, in networking we always have redundancy, because we want to give our customers the proper availability, whatever agreement is being signed. Okay, the SLAs, what we say, the agreement what we sign, we ensure that whatever we have written, we are up to that mark. So when we are talking about mesh topology, it's a kind of redundancy which you offer to your client by having a specific connection from both the sides. So we have this kind of topology mesh connections in our systems where we connect each and every router to every other switch. So when we'll be learning about the two-tier structure architecture or the three-tier architecture, I will be showing you this mesh connections. So the advantage, what you see is you have a dedicated link. So you have a dedicated bandwidth allocated. So there is, so the traffic problem can be avoided or the congestion can be avoided, I can say. And in any case, if there is a link failure between any two PCs, the other links are not affected. So that is the another advantage, that it is quite robust. Then you can see there is, it gives you a good privacy since you are having your individual cable connected to that particular system. You don't have any kind of security issues here. Things are being kept private. Fault identification and isolation. Isolation is quite, I can say fault isolation is quite easy because we can say in terms of which PC or which connection has gone down or which connection has gone up. We can talk about very precisely when we are talking towards the mesh topology. The disadvantage, as I said, the amount of cabling and the amount of input output ports required for having this topology, the sheer bulk of the cables, that is quite, it will take quite a lot amount of space, and the hardware required to connect each and every device is really very expensive. So mesh topology is used where we see that there is a WAN network, wide area network, and we, wherever we see all our telephone regional offices, like we have in our country MTNL and BSNL. So they have a kind of mesh topology in their regional offices. The connections are a mesh connections. Okay, so I'll be giving you applications for each and every topology so that you get a very good idea that which topology is used under which applications.
Hello.
Yeah.
I just want to explain the concept of redundancy again. What do you
Okay.
mean by redundancy?
Redundancy means, for example, there is only redundancy means, for example, now if I'm logging to Amazon server, let's say I'm shopping and I'm visiting the Amazon website. So in a day, during different hours, the traffic is different. Maybe I can say the late nights or the late evenings, the at peak hours, there is more of request to the website. So it would never happen so that if there is a load, the load or the traffic is more than what it can handle, the server can get crash. So in such cases, there is always a redundancy that you have again a one more server so that it can distribute the amount of work, or if one fails, the other is still up. So in the same way, when I'm talking in terms of networking, if we have a connection between router A and router B, just having one single connection is not, basically, if I am purchasing it from a service provider, I'm taking a lease link from a service provider to connect my branch A and branch B. I'm paying the money to ensure that it should be available 99.99% of times. Even that percentage, what I talk in terms of 99.99 or 99.92 or 99.9, for us, it will not make a sense, because for us, I may feel that, or we may feel that it's a very small number in decimals I'm talking about. But when I'm taking a lease link from a service provider to have a connection between my two branches, so I ensure, or I get a specific kind of there is a specific agreement which is being made that this should be available, the service should be available to me round the clock for so and so many years, and for so with so much of accuracy, there should be not much of a link failure. So that means what, we are ensuring a redundancy, that if there is a one link, if there is a failure over a one link, or if any of the interfaces of the devices goes down, then I also have another link which is there parallelly to it, so that if one fails, the other is up. So on the same time, whenever the one is going down, the other will automatically come up. So in that manner, I ensure to my client that the redundancy, through redundancy, I'm still giving the service which I have promised. So redundancy is when I'm talking that I have another set of devices or another set of links ready, which is already created along with it, so that if one fails, the other goes up within that moment. It should not take any time to go up or to switch to the redundant link or to the redundant devices. So basically, it's you are keeping one more copy of a device or and a link, so that if one fails, the other takes its role and give the service what it has promised. Am I clear, sir? Hello?
Yes, everything is okay. You can go on.
Clear.
Okay, okay. So moving on towards the next topology, which is a very famous topology, that is a star topology. Star topology is where we have one point of contact. So it is a boon as well as a curse, I can say, whereby it is like you have one central controller and all of the devices are connected to this controller. So if that controller fails, then your entire system or the network goes down. Okay, so here you see that there is a specific central controller which will be like a hub or like a switch, what we saw yesterday. So where the traffic is being directed from one device to the other device, and whether to use a hub is now obsolete. It is not there anymore in the system. But just because we try to understand how switch, in order to compare why switch is intelligent and how it is good, we need somebody to compare, right? So we have this hub always to try to give some kind of to give some good qualities about switch. I try to compare it with the hub. So what are the advantages? It is less expensive than mesh since each device is connected only to a hub. The installation and the configuration is very easy. The cabling requirement is very less. And again, if any of the link gets failed between the hub and the system, only that link will be affected. No other link will be affected. But yes, the disadvantage is very evident that if the central controller fails, the dependency is on the central controller. So if it goes down, then the whole system will get inside deadlock. Okay, so the system will be dead that time. Most of the time we see the applications of this topology in LAN. Okay, there is another topology which we use for LAN network, but this is again a very, very famous topology which we use for designing our LAN. This is another one, that is a bus topology. This topology is like a multi-point topology. So here there's one long cable which is being laid down, and then you just have some taps or connection which is being made from the cable to the device, and that is known as a drop line. You see there's a drop line and a tap. These are the two terms which are used. The drop line is used to connect the device and the cable, and the tap is a splitter which cuts the main link. And this allows only one device to transmit at a time. So here your data link layer, which I had discussed in the last class as well as in the day before class, that somebody has to control the medium. Somebody has to understand who will access the medium. Medium access control, which is the function offered by the data link layer, this comes into picture when we are talking for the bus topology. That only one device at a time can transmit, otherwise a collision will happen. So when the collision happens, so your message gets corrupted and then it is not received to the desired receiver. Installation is very easy. That is one of the big advantage. The cabling requirement is very less. The disadvantage is the fault isolation becomes very difficult, that since we have to wait for who has to send first, there is a kind of algorithm which is running. we say that there are different algorithms when we talk about medium access control. This again I'll be discussing in very detail, because to discuss that algorithm will itself take one big lecture. So algorithms are like CSMS-CD, that is collision detection, carrier sense multiple access, and then also we have for wireless medium we have CSMS-CA. So for wired medium we use CSMS-CD, that is basically meant for Ethernet, and for wireless medium we have CSMS-CA algorithm, which is running to ensure who is going to access the medium, and so that the information is being passed properly. So the disadvantage is already seen here, that it is difficult to add new devices once you, because it is being decided by the length of the cable, how many devices can be added into it. And if any fault is there in the backbone, because if any fault is there in the backbone, then obviously the all transmission will stop. One such example which I can relate with this in real-time scenario, if each one of us have seen those optical fibers which is laid down under the roads, those are like, I can say, a kind of bus topology. It follows a bus topology. So a very long channel or cable is being laid down under the road or under the submarines in order to give you the kind of connections which we say fiber to home, FTTH, the fiber to home connection which we have these days, in order to get those amount of bandwidth what our service providers promise, that we will have 40 Mbps or 50 Mbps or 1 gig 1 gig speed. So those are basically, I can say, one of the example of bus topology which you can relate, that there is a big backbone which is being laid down, and then there are connections which are made to each and every home. Those are fiber to home technology, what we say. So if the backbone, because most of the time in the backbone network optical fibers are used, since it has a good advantages in terms of speed, security, and bandwidth. So if the backbone falls or it fails, then the whole transmission gets stopped. So bus topology is one such example I've already given you. Then we have a ring topology, where we have a kind of a system. Again, this is quite more related with the, I don't know if you have heard about Sonnet or WDM technology in optical fibers. Now these technologies, they use this kind of topologies in order to, uh, properly design the system. So ring topology is where we see there is a kind of token which is being passed from one system to other system in order to understand who is going to transmit the information. So whoever has a token, only that system will be able to transmit its information. So it is followed like a proper ring manner. There is a fault in this case, because you see that the traffic is quite unidirectional, and if any of the link fails, then whoever has a token will not be able to transmit it to the next system. So this is the very big disadvantage of a ring topology, that if the system link fails, then you have entirely your whole system will get stopped. So you again see there is a redundancy. You have a primary ring as well as a secondary ring which is seen. So what I was discussing about redundancy is what you see in this picture, that if there is a ring, primary ring which fails, then you have another secondary ring to take up or to take care of the redundancy. Okay, so advantage is very easy to install, configure. However, since you see that if there is a break in a single ring, the entire network can get collapsed. So this is what you see is the ring topology. In practical scenario, we always have a kind of hybrid topology. You can see there is a start which is being kept. There is a backbone layer, so that becomes backbone channel is your normally considered as an optical fiber technology. Then you see a bus topology which is being made over here. So in my real-time scenario, I always see that there is a hybrid technology or a hybrid topology which is being followed, so that we can take the advantages from each of those topologies and try to create the best one. So this was related to the topologies. Okay, the bus, ring, star, and we discussed about mesh. Okay. Now moving on to the next slide where I'll be discussing about, okay, just a minute, there's some issue.
But give some real world example of hybrid topology.
Hybrid topology, so you mean to say? When we are designing in our campus network, we follow this kind of approach where we see that there is a bus topology as well as a star topology. When we are designing our LAN, okay, we have a star topology as well as a bus topology, which we can use. Since the main cable, what we are using, okay, if I want the connection, okay, just a minute, sir. I don't know what is the problem happening. Okay, somehow, I don't know, my computer has got stuck.
Did you try doing slideshow?
Yeah. I'm just trying to do it. I don't know why, but my cursor is not moving at all. Okay, just a minute, guys.
One question, ma'am.
Yeah, sure.
Can I use the switch in the star topology as a
Yes.
central controller?
Yes.
Exactly.
We normally use a switch only. These
Okay.
days we don't use hub because it's of no use since it doesn't have any brain to
Okay.
forward, whom to forward the packet, it doesn't know. I will be discussing about the networking devices only now, shortly. Just a minute. I don't know, somehow system. Okay, is this slide visible enough or is it still small?
It's very small, ma'am. I think you have to restart your system.
Yeah, I'm just trying to do it. Wait a minute.
I think you zoom your slides. It is only 25%.
I'm just trying to do it. Wait. Yeah, is it visible now?
Yeah.
Okay. Okay, sorry for that interruption. I don't know at times what happened. Yeah, so I'll be discussing about networking devices here. So these are the different networking devices which we have: repeater, bridge, hub, switch, router, wireless access point, servers, controllers. There are many more. So as you asked me that whether I can use a switch in the star topology, yes, we
Yeah.
use a
Yeah,
switch
you use it
only
to
in the
intercept
star
too.
topology these days. Hello?
Yes, madam. Yes, clear. Yes.
Okay. Okay, fine. So basically, these are the different devices which I will be showing you now. Means through the slides as well as through the, I can show you to the through the packet tracer how to get acquainted with the device and its functionalities. We should know which device should we use before we pick. So now repeater, bridge, and hub. These three devices are more or less not in use much. Though repeaters, I can say they are there in picture because it boosts the signal when you are traversing the packet from one place to the other place. So what happens is, since we know that in the real time, in the real time scenario, it is going in the form of a signal. Okay, either in the form of an electric signal or electric pulse, I can say, or in the form of light if I'm talking about optical fibers. So in any form, we know that the signal which is transmitted at the very end or below the physical layer, it's in the form of electrical or optical level. So what happens if you transmit a signal, or if I just give you one example, like when we talk on a mobile, in a mobile communication, we are sitting here and somebody is sitting at very, maybe let's say 100 kilometers, 500 kilometers, or some other continent. We are trying to talk from one place to other place. So in the towers which is being set up around around your area, or how whoever is connecting your call to that desired call, there are set of repeaters which are placed on those towers so that your signals are boosted. Okay, because there is a natural philosophy that the signals, when they travel, okay, their strength or their power, I can say, the value gets decreased when they are traveling a longer distance. Okay, but now when I'm talking in terms of mobile, there is a different phenomenon, or there is a different electromagnetic waves which are being traveling, and their power or their value gets decreased. So you need to increase the strength of the power and then give it to the next station who will be forwarding your call. In the similar manner, when I'm talking for a computer communication, when I am placing my device, I am laying down the cables and I want to communicate a device A to a device B, which maybe is located in my far away from my building. So through the cables, the communication is been happening, or through the cables and the devices. So you need repeaters to boost your signal, to give a shape to your signal, because the shape of the signal also gets deteriorated due to interferences, due to many more noise factors which are added up. Okay, so your actual information signal, the shape of the signal gets deteriorated. So what you want to get the shape as well as the strength back, so that the information what you're actually passing is received correctly. Okay, because zeros and ones are what the physical layer. Okay, in the physical layer we have seen that all the information which we have taken it right from the application layer till all the layer, everything is converted into bits. So zeros and ones which are being transmitted, so if your zero is being transmitted at the receiver, it should not become one, or if the one is being transmitted, it should not become zero, because there are noise factors, there are interference, the cable adds their own interference, or there is a cross talk which may happen. So because of all these things, because of noise, there the signal which you are transmitting may get corrupted. So you want to, other than corruption, I can simply say that if their shape changes or their strength changes, it will be difficult at the receiver side that to distinguish whether the given information or the given bit is a zero or it is a one. Now this, I'm talking more about a little of digital communication coming up here. So repeater is an important component in your architecture. So its job is to boost the energy or boost the signal to a specific level. Bridge is again, I can say the switch what we are talking these days when we are using switch, it has been derived from the bridge itself. The concept is coming from the switch itself. So, but bridge is not used more or less. Switch, router, they play a very, very important role in our networking architecture. So coming back to the repeater, as I just said, this is how the device looks like, the repeater. So it regenerates the incoming electrical, wireless, or optical signals, the way I was talking about. With the physical media like Ethernet or Wi-Fi, the data transmission can only span a limited distance before the quality of the signal degrades. So repeater attempts to preserve the signal integrity and extend the distance over which the data can safely travel. It removes the unwanted noise in an incoming signal. It can't filter the signal traffic. So it doesn't know which signal, like for example, we say that this signal needs to be a certain frequency above which the signal has to be filtered. Those things, those jobs cannot be done by the repeater. To identify which signal is good or which signal is bad, that is not what this repeater's job is. Its job is just to reshape the signal. If it has got deteriorated, the shape of the signal has to be preserved so that the receiver knows what is 0 and what is 1. The receiver should be able to distinguish that. So this works in the physical layer, repeater. It's a very important, it's doing a very important job. Hub, sadly, this is no more in place because it has no intelligence in it. It was just trying to take the data and try to broadcast it to everyone. So the star topology, which we saw just few minutes back, the topology had a central controller. So the central controller was trying to basically dictate or basically try to like acting like a head. So the central controller, if it has intelligence in it, it will know whom to forward the packet. If a sender is transmitting the packet, should I forward it to all the ports and just try to block the bandwidth or just try to create a congestion, or should I give it only to a specific recipient? That intelligence was not there in hubs. Okay, so it was just taking the information and trying to broadcast it to every other port which was there or to all other PCs which was connected to them. So this is no more in picture because of its because if this kind of scenario, you can understand that in under such scenario, the information will more or less, there will be a lot of congestion and the bandwidth will be simply occupied for just trying to broadcast and occupying the, just trying to give that amount of bandwidth will be simply choked up because you're trying to transmit or broadcast it to everyone. Hence, hub is no more in picture. It is obsolete. Though we have these active and passive hubs, this is just for information. Coming back to the next, which is bridge. Now, bridge is similar. It is basically used to join the similar topologies, or I can simply say it was used to extend the LANs. Okay, so it can filter the traffic on the basis of the MAC. And if it is aware of the destination address, destination MAC address, it will only forward that particular frame to the relevant port only. Okay, so it will not try to broadcast unlike you saw which in hub. So it will only forward to the relevant segment, I can say. So they are more intelligent than repeaters, but are unable to move data across multiple networks simultaneously. Okay, so just joining the segments. Okay, I can show you the diagram how it looks like. So here you see there is a bridge where you have one corporate LAN segment, one manufacturing segment, a database server. So it is just trying to connect the similar topology. Okay, but again, we no more use this bridge. We are nowadays using a more intelligent device, which we saw in the yesterday's class also, and that is your switch.
Yeah.
So the switch looks like this.
Excuse me.
Hello.
Here you have told that in the bridge that it filters the traffic on the basis of MAC address.
Yes.
What does it mean?
A specific MAC address, the way yesterday we saw that if a specific request has come, it will check into its MAC table.
How it is filtering?
Filtering in the sense the MAC table, it has its own table.
Okay.
In the table, it will look for the MAC address, and if that MAC address, destination MAC address, to whoever it wants to forward the packet, it will only forward in that segment.
Okay. Okay. Fine.
It has the ability to filter which MAC address it is and whom it has to be forwarded. It doesn't just follow blindly to broadcast to everyone. All right. So the same features is what the switch is also having.
Okay.
Switch is considered to be an intelligent device, unlike hub, which is considered as a dumb device, because here it has the ability to know which port I should forward this particular frame which is coming up. Because it is falling under the layer 2 device, I will refer to the protocol data unit, which is frame. Okay, so there are a lot of points which we are going to discuss about switch, very, very important from the interview point of view, as well as from the exam point of view. How does a switch function? What all characteristic does a switch has? So very, very, very important. So guys, just wake up if you have just fallen down because of the lot of theory which we just discussed. So coming up to the switch, firstly, as I said, it's a layer 2 device. It's an intelligent device. As soon as it receives the frame on its port, it will read the MAC address, refer the MAC table, and then take the forwarding decision. Okay, so a lot of processing is required here. You can see that when I am talking about the device, you have to understand this like a normal device, like a normal computer or a laptop, how we use. So if we are performing any kind of computation, or we are trying to do any kind of, software things which we do, so we are trying to occupy our processors over there. So even when a switch is trying to, read the frame or receive the frame, then read the MAC address and then refer the MAC table and then take the forwarding decision. So there is a lot of processing required over here. So it has a memory, like we have a memory in our computer systems, the RAM, everything is similar to what we just understand for our computer systems. It is just that you don't see a kind of operating system like we have in our computers. The operating system, what we will see in the switch or the router, will be based on the company. Like we have Cisco, iOS, we have Juniper, we have different operating system based on their vendors. Okay, so it will have the similar features or the processing system like we have for the other kind of devices. MAC address is a layer 2 address. MAC table is a layer 2 table. Hence, switch is a layer 2 device. Why do we say that switch is a layer 2 device? Because it uses MAC address for forwarding, for taking the forwarding decision. So it's a layer 2 address. Hence, we say it's a layer 2 device. Now on receiving the frame, see, this is very, very important. All the important points I have just jotted down on the slide so that you can also read, or in case you have missed any of my points while I speak. On receiving a frame, the switch will open the L2 information and it will try to, first what I said yesterday, that it will first check who you are. Okay, it will first check, okay, the frame has come from where? First, let me check that. And it will not directly go to the destination first. So it will first check from where this frame has arrived, which MAC address you are holding it, which port number you are sitting on my which interface. I'll just refer it to my table. If your entry is not there, I'll update that entry in my table. Then, as I said, switch segments the network, whereas hub extends the network. It segments the network means it knows whom to forward the packet because it knows to take the decision. Okay. Because switch refers the MAC table, hence the MAC table should be populated with the MAC addresses. Now this is very important. Yesterday, I forgot to show you the MAC table, address table inside the switch while it was trying to, send the packet, ARP packet, and then the ICMP packet. Okay, when it started the ARP packet for the first time, even the switch MAC table was empty. There was no entry in the MAC table. So as soon as the ARP packet went, the ARP request went, it saw from which MAC address it has come and it is sitting on my which interface. So it updated that entry into its table. Similarly, when it got the reply from the other PC for the ARP reply, it again saw that which MAC address is this, it is sitting on which of my interface. So let me enter this entry. So switch is learning this on the basis of the communication, the kind of communication you want to have. So the switch will update its table accordingly. So firstly, what you say that the administrator can statically make some entry in the MAC table that if so-and-so address comes, then it has to be forwarded to so-and-so port. So administrator has the right to statically configure the MAC, or as I just said, that it can do the self-learning of MAC address in the MAC table when the frame traverses the switch. Okay, so as in when the frame is traversing between any systems, so it will try to learn on its own if the administrator is not populating it. Just like yesterday, I didn't do anything inside the switch. Whenever the ARP packet request was going, the reply was coming. That time itself, the switch has just tried to refresh or made a new entry in its MAC table. So I hope these 3 to 4 points are very clear from the slide. It's an intelligent device. It's a layer 2 device. It takes in the forwarding decision on the basis of the MAC table. And then the MAC table needs to be populated via administrator way, via static way, or it will learn on its own when the frame traverses the switch. The next point is, because it is doing the self-learning, okay, because the switch is doing the self-learning, we have to know how much of capacity it has, okay, like what could be the maximum size of the MAC table. Because if the size of the table goes very, very huge, then that much amount of processing would be required. And if that much amount of processing is required to search which port I have to forward this MAC address which has come, then there will be a kind of latency also, because it is checking first now which particular frame has to be transferred to which port. So if there are a lot of entries present in my MAC table, then it will take time to do the forwarding or to take the forwarding decision. So two things what we see here, or three issues what we see here, that there is a high memory utilization if you have a huge table, high CPU utilization because that needs to be processed, that needs to be checked which interface that particular address is sitting, and hence the decision taken, there will be delay in taking the forwarding decision. So to overcome these issues, Cisco defined a limit of 4096 MAC entries in a MAC table. Okay, that you have this many entries only in the MAC table. And again, secondly, if any of the MAC entry or if any of the PC is not sending any frame to a, for more than, or let's say in 5 minutes, then that particular entry can be removed from the table. Okay, so if not more than 5 minutes, if it will set a timer that this particular entry which I have just made, if another frame from the specific source comes to the destination, then that entry will be again refreshed, and it will be again, the timer will be again recreated for 5 minutes. And if there is no such communication happening from a specific PC or from the same PC, then it will try to remove that entry. And then in this manner, the huge MAC table, the issue of huge MAC table can be catered. So maximum 4096 entries, and a better solution was that you keep a timer, and if a specific PC is not communicating, then better try to flush that particular entry. So this is how the switch works. The switch MAC table and the switch forwarding decision, that is what we have understood. Now the last thing which is very important, generally asked during the interviews, that what happens when a frame comes over a switch? When the frame comes on a switch, it will create multiple copies of a broadcast frame received on a port and forwarded to all other ports. So it behaves, when does it broadcast? We have to understand, when does a switch broadcast? A switch will broadcast the frame when it sees that there is no MAC entry in my table. If I don't know where this interface or where this frame has to be forwarded, that entry is not known to the switch, then it will make a multiple copy of the same frame and try to broadcast to all other ports. Okay. The second thing what I say over here, that switch cannot broadcast, but will forward the broadcast frame received on all other ports. Now, what does this mean? That it cannot broadcast, but it will forward the broadcast. It cannot broadcast just means that it will not play with any of the contents of the frame. It has no way to change or modify the contents of the frame. That is the meaning of broadcast. That when I talk about broadcast, you need to understand that switch has no right to manipulate any content of the frame. It will forward the broadcast frame whenever a MAC address FFFFF is there in the frame. It will try to forward the broadcast frame, but by itself, taking on behalf of somebody, I am trying to do it. It will never do that way. Okay. And it will not participate on its own. That is the meaning of it cannot broadcast. Okay. It will not participate on its own, or it will not try to communicate. It is not meant to communicate with any other PC. So that is what it means. It cannot broadcast. Okay. L2 switch is a technology device which facilitates communication and does not participate in communication, and devices which do not participate cannot broadcast. That is a meaning what I meant to say, that switches cannot broadcast. Unlike router, we will be seeing that it will be able to modify the content of the packet. So it has the ability, or I can say that it participates into the communication. Okay, so switch cannot broadcast, but it will forward the broadcast. Unlike router, I will say that it will broadcast, but it will not forward the broadcast frames. It will just drop the frame or a packet. If anything comes as a broadcast packet, it will just drop the packet. It will not forward that packet to any other network. Okay. This is very, very important, guys, to understand about broadcast and collision next, which I will be talking about. So this is important. L2 switch, we do not configure IP. It's a data link layer. Layer 2 is not meant for IP addressing. It is only meant for physical addressing. So there is no IP configuration which we can do on a switch. Layer 2 switch.
Hello?
But if I say about a layer 3 switch, which has a function of both a router as well as a switch, then there I have the provision to configure the IP. So just mind this very well, that for a L2 switch, I cannot configure an IP. However, for a router or an L3 switch, if I'm talking for an L3 switch, there is a functionality of both router as well as a switch within the same device. So I can configure an IP over there. Coming back.
A question, please.
Sorry?
Question.
Yeah, sure.
I have a question. So you talk about a bridge and a switch. I want to know the main difference between two, since all of them length MAC address or populate their table with MAC addresses. I want to know the main difference. And moreover, you were talking about you cannot configure IP address on a switch. So how can you manage the switch if you want to terminate into it?
Exactly. So for that purpose, where we have to manage the switch, or you have to remotely access the switch, then only for the management purpose, we have this VLAN concept, wherein the VLAN, we try to give an IP address, and that is only used for remote accessing. As such, we don't configure the IP the way we configure it in our systems. Let's say yesterday we took 3 computers and we gave some IPs to that computer so that we could ping that computers, we can communicate with that computers by the IP. But for a switch, I didn't configure anything. I just tried connecting those pieces with the computer, with the switch. So there was nothing, no configuration of IP required on a switch. However, if I have to do a telnet or remote access of that switch, I will be definitely configuring one IP, but not on its interface. If you see, Yesterday, when we talked about the switch, there were 24 fast Ethernet ports and 2 gigabit Ethernet ports. Okay, or I can say 24 fast Ethernet interfaces or 2 gigabit Ethernet interfaces. Those interfaces, there was no option that you go and configure the IP over the interfaces. Okay, you can configure an IP on a VLAN, which we create, that is just used for the remote access purpose. So this is what I was going to come about in the next slide, that you can have an IP configuration, but only on a VLAN, so as to have a telnet or a management IP. What you see here, that the IP address, what we assign to the VLAN is known as the management IP, and it is used for telnet or SSH purpose only.
Okay.
Okay.
And, okay. And what is the main difference between a switch and a bridge? Since they all
they both have the same functionality. I can say bridge and a switch, they both have the same functionality, that they extend the LAN. Okay, they try to join the two LAN or join the two network segments which are having the same functionality or the same features. But a switch, what you see over here, that other than trying to have this kind of information of broadcasting, what I am talking about. Okay, the broadcast domain I will be talking about, the collision domain I will be talking about. More or less, we say that the bridge and the switch, they are one and the same, but more conveniently, we say that we use a switch. It is obviously the features what I showed you for a bridge, that it is able to filter the MAC address and take the forwarding decision to connect to the specific segment. But here we don't have only two segments like a bridge. Normally what we consider, if a bridge is there, we suppose that a bridge is connecting only two segments of a LAN. Okay, multiple segments can be connected over a bridge to or over a switch to, but more precisely we use switch. We don't go for a bridge.
Okay.
But more or less, I will try to, even if I will talk about the spanning tree protocol, there again we'll be using the term such as bridge. We have these BPDUs, we have the root port. More or less the principle of bridge we are going to again use in the switch also. But we don't have a bridge device nowadays which we use for in our networking. When we try to build a network, we normally refer that there are different series of switches which Cisco has. If I'm using Cisco's devices or Juniper's devices, so we just use those devices based on the features, functionalities. Those series are being picked up, and we just try to connect our components.
Can I make a little contribution?
Sorry?
Can I make a little contribution?
Contribution?
Yeah. What I want to say is that when it comes to a bridge and a switch uses ASIC to learn the MAC address. So it is more or less a hardware specific. While that makes the switch more faster than the bridge. Bridge uses a software to learn the MAC addresses. So I think those are the main difference between the switch and the bridge. I mean, for the sake of the CCNA, they normally ask these questions. That's why I just want a clear difference between the two.
Okay. Thank you, Clifford, for adding up to those points.
Okay.
Another question, ma'am. What are the protocols which are working on the switch? Like for the self-managed, you told that self-learning of the MAC address in the MAC table, some sort of intelligence, some sort of protocol also which are working on the switch.
See, we don't say in terms of protocol. See, there are certain types of like spanning tree protocols which is already there in the switch, but that is to avoid some other concept which we say loops. In order to have a MAC address learning, it is trying to trying to read those entries and trying to write that in the MAC table.
I mean to say that which are the things which make the switch intelligent? Either it is a like either in terms of, you can see the AI, artificial intelligence, or what are the why the switch becomes.
No, the intelligence is only in terms of taking a good forwarding decision, that I know whom I have to forward. If there are 24 ports in my switch, and if a frame arrives in port number 1, and if I have a table, MAC table entry that this particular destination is sitting in my port number 5, then the switch will take smart or intelligent decision to only forward in that relevant port number 5. It will not just try to broadcast to all the 24 ports just because it has received one frame. That is how it meant to be intelligent. Unlike hub, which was just trying to broadcast, whoever is just forwarding the packet, it is just trying to broadcast it to everyone. It is not seeing who does A want to speak to only B, or A wants to speak to only C. It does not see anything, the destination. It just tries to give the packet or the information to everyone. So that is why we refer this intelligence in terms of forwarding decision, that if that switch knows whom to forward that particular frame, if the entry is there in the MAC table.
And the second one, you have mentioned the word latency. What do you mean by latency in the computer network?
Latency is a form of a delay. I can say that if I have, let's say in your database, if you are keeping thousands of entries.
Yeah.
So thousands of entries, what we say, okay, which is there, if that particular entry is there in the 1000th place, you have to read the data from first, second, third, fourth, fifth, sixth, seventh, and then you will land up to the 1000th, right?
Yeah.
So till that time, the packet is kept in the buffer, the frame is kept on the buffer, and there is no forwarding decision which we can take till the time I find the entry.
Okay.
So there is a latency in the form of forwarding the frame, because I have to take that much amount of processing is required to find that entry.
Fine.
Yeah.
Clear. Thank you.
Great. So VLAN, will be talking about virtual LAN. Why do we need virtual LAN? It's a very, very, very important concept in under switch. Okay, so as of now, just try to see that VLAN 1 is the by default VLAN, which is there inside a switch. And it is like all the ports are a member of VLAN 1. Okay, all ports of your switch are by default a member of VLAN 1. Okay, we'll be talking about VLAN in tomorrow's class. I'll be talking about VLAN, how to configure a VLAN. We'll see that tomorrow. Okay, as Clifford mentioned, that most of the time when we take up the device, a new device comes to your system, only for the first time we do some actual configuration, the basic telnet configuration or the remote configuration. That configuration we just do as soon as a new device comes under your enterprise or a production environment. So you just do that much, and then afterwards everything happens through remote access. Whatever configuration you want to do, you want to add, you want to remove, all these things happens through remotely. So for that we need a IP. Just because you cannot do it randomly, you need an IP. So that IP is only configured under VLAN. Okay, it is not configured into any of the interfaces. It is only configured under the VLAN for the management purpose only.
So okay? in the course you will teach about both physical and as well as remote.
Yeah.
Access. Fine.
I'll just show you, like in actual sense, how do we do? Let's say you have brought a new switch.
Okay,
you went to the market, you bought a new switch, and you got a cable, which cable you should use to configure your real switch, what you got, then how you should connect to your computer, which terminal or application you should now open, and then what configuration you should start. All these things I'm going to show. Okay, so you need not worry about it. The last part in the switch is very important. Every port of a switch is a member of separate collision domain. Switch is a multiple collision domain device. And every port of a switch is a member of same broadcast domain. Switch is a single broadcast domain device. A very, very favorite question of the interviewers. Whether switch is a single collision device or a multiple broadcast device, or a multiple broadcast device, single collision device. This is how the interviewers try to confuse. Now, what do you mean by separate collision domain? Whatever collision happens at one side of the port does not travel to the other side of the port. The collisions are kept separate. Whatever is happening at one end does not go or travel to the next end, so as to disturb the other communication happening inside other port. Okay, so we say that it is a multiple collision or a separate collision. It has a multiple collision domain. Whereas when we talk about the broadcast domain, it's a single broadcast domain, because whatever frame, if it is a broadcast frame coming up, it will forward to all the ports. If it doesn't know any entry, if there is no entry in the table, again it will try to broadcast to all the ports. So it has a single broadcast domain and it has a multiple collision domain. This is very important to just fix it in your brain. Single broadcast domain, because under two scenarios, switch tries to broadcast the forward or broadcast a frame. Okay, the two scenarios are: the first scenario when the frame itself has a MAC address, which is a broadcast address, and the second scenario is where the switch does not have any information about it, or there is no entry in the MAC table of a specific port or a specific destination where it is sitting. Under this scenario, under these two scenarios, the switch tries to create a multiple copy of the same frame and try to broadcast to all the ports which it has. So hence, this is a single broadcast domain device. However, it will not try to forward your collision happening at one side due to multiple PCs talking at one side. Okay, I can put the way yesterday we saw something like this, that under port 1 there were 4 devices which was connected. Then under port number 2 there were 2 devices connected. Under port number 4 there were 4 devices connected. So under the port number 1, if there are 4 devices connected, so there are chances that the collision may happen if somebody wants to talk. Triple A wants to speak to triple D, or it wants to speak to triple C. So in that manner, if there is any collision happening at one end of the port, that collision will not be forwarded to all other ports. So it keeps this collision separate. That is the meaning of multiple collision device. So I guess this is enough for the day. We'll be talking about router tomorrow. I'm giving a short quiz now, because since we have understood the different types of communication today, we understood the different networking devices, though we are yet to understand the router. But switch was enough to be like, I just want to show you on the packet tracer. Let me show you on the packet tracer.
I had 3 questions really quick. If you connect 2 switches together, will that become one big broadcast domain, or will each switch be its own broadcast domain?
I'm sorry, I did not hear you clearly. Can you just speak?
Yeah,
again?
Can you hear me now? Is it better? Hello?
Hello, yeah.
Is this better now?
Yeah, now I can hear you clearly.
Okay, if you connect 2 switches together, right, then will both of the switches be one broadcast domain?
If I'm connecting 2 switches together.
Yes.
So is it a broadcast domain you're talking about?
Yeah, will it be one single broadcast domain, or will each switch have its own?
Each switch will be under one broadcast domain.
Even if you connect 2 switches together with an uplink port.
It is under one broadcast domain, because it broadcast meaning over here, the domain broadcast domain meaning over here is it forwards the broadcast packet to all the ports. All the ports. So that is why we see that if there are 2 switches which is connected with 2 cables, let's say, so there will be a kind of a broadcast loop, or we say that a kind of a storm which is being formed. So to avoid that, we have a spanning tree protocol.
Okay. My second question is, in the future, when you go more deep dive into switches, will you show us how switches are stacked in Packet Tracer and how to configure stacked switches?
The stack of switches you're talking about?
Yes.
You want me to demonstrate that?
Yeah.
Sure. In the future, when we'll be going in sequence with the exam exam modules, what I just showed there, I will be showing you everything in terms of lab also.
Okay. And then does the exam module also cover L3 switches configuration as well?
L2 and L3 switches, they are there. Yeah.
Okay. Thank you.
Yep. Okay. So guys, just go to your chat box. I'm just trying to paste the link. Just check out whether you people are receiving it.
Yeah.
Okay, just go and try out. I don't think so it will take much time. Though there is one question which I've asked, I've not covered today, but let me check how much do you know the difference between a router and a switch. There is one such question.
I'm sorry, what does place mean?
Sorry?
There's a question called place.
Simple coupling method.
There is a question called as?
Place. P-L-A-C-E.
Just a minute. Yeah, which
I'm
question?
sorry, can you repaste the link?
Yeah, I'll just do it. A place means
Okay,
your place of residence, wherever you are coming from. That's not a question, that's just an information. Since people are coming from diversified region over here to understand, so we get an idea.
Here is one place of the student.
Yeah, place where you're residing. I guess that question was incomplete in that sense.
Just
where are you coming from? Just that's an information.
Okay,
just
okay.
to know from where across, like we have people coming from different states, cities.
Just explain the broadcast domain again.
The broadcast domain, you want me to explain?
Yes.
The broadcast domain is basically a domain where I'm talking. Just a minute, I'll erase this out. See, broadcast domain is basically, as I said, that under two scenarios, my switch keeps all the ports under the broadcast mode. That means if a frame arrives to the switch and there is a broadcast address which is there under destination MAC address, all FFF. Yesterday, as I said, that if the destination MAC is entirely kept as broadcast, if I don't know the MAC of the PC whom I'm talking, so I'll initially put FFF in my ARP request.
Okay.
So this is what the switch also understands, that this is the destination which is broadcast. So that means I have to forward it to all the ports.
All the ports. Fine, fine. And another condition?
And another condition where in its MAC entry, in its MAC table, that entry is not there. For the first,
is not there. Okay.
Yeah, means the MAC table keeps the port number, the relevant interface,
Okay.
and the MAC address corresponding. So if a specific MAC address is arrived and whose entry is not there in the table, that to which port I should forward this destination MAC address, something, let's say AAA has come, AAA wants to speak to BBB.
Okay, then it will broadcast to all the computers.
Yes, yes. Okay. Then it will create multiple copies and give it to all the ports.
So I want to go back to the broadcast domain. You said it will forward the packet on all ports, except the port where the source it originated from. Is that correct?
Right. Except the port from where it has got the message. Only except that port, it will forward it to all of the ports.
Yes. So if I connect two switches together, right, with one cable, how will it form a loop? Because it won't, because switch 2 will get a broadcast packet on, let's say, port 1. So it won't forward the broadcast packet back on port 1. So it won't form a loop, right?
How the loop will be formed?
The loop will be formed when we have a connection like this. Let's say I have a switch over here and over here, and I'm just connecting two cables between the two switches.
Oh, two cables. Got it. Okay, two cables.
Okay.
Under this scenario, if there is this is one port, this is second port. Okay. So this port, now from port number 1, some frame or some PC who is sitting here. Okay, let's say this is 1 and 2, and here some PC on port number 3 and 4, somebody else is sitting. So now from port number 3, some packet has arrived, which is a broadcast frame. So the switch is going to forward the frame to port number 4, to port number 2, and to port number 1. Now this port numbers 1 and 2 will forward it to the next switch 1 and 2. So from wherever it has received, accept that port. So except that port, it is going to forward it to all other ports, right? So except port number 3, it will forward to 1, it will forward to 2, it will forward to 4. But what will happen in this case now, port number 1 will try to forward the packet to the next switch now. Now this will take the packet or the frame and then accept this one from where it has got, it will push it to all the other ports. So let's say it will push it to 2 also. Now since from 2 also this packet is coming, so now from here the packet is coming, accept this thing, this will push to all of the ports. So again, this will forward it to port number 1. So likewise, there will be the frame which will go on just, the frame will try to move inside the same loop.
Okay, so when you talk about a loop, is simply just a frame or a data that is not able to reach its destination. It never reaches its destination. Just yes.
It's exhausting the bandwidth. It is exhausting. Yes. There is a kind of congestion.
They continue to rotate through the system.
Yes.
It will never reach its destination.
Right. And in that case, what happens is the actual information which wants, let's say there was some actual information which the port number 3 wanted to give to some port number, that information or that communication is being halted because your switch is just busy in, forwarding the packet forwarding the frame from one port to other port. It is trying to create the multiple copies and it is involved in that process. So the actual communication is being halted here. So to avoid such situation, we have spanning tree protocols.
Yes.
So guys, most of the time people just say that the information was not received to the destination, but there is another real-time issues that occurs due to looping, layer 2 looping. First thing you need to know is L2 looping or whatever frames are just getting broadcasted or looped, they do not contain TTL value, that is time to leave. Now what happens are these are the most dangerous looping when compared with L3 looping, because L3 looping, what occurs, they have at least TTL value, time to live. Okay.
Right.
So
Right.
if a packet is moving in and forth, at certain point, the routing loops get expired automatically, but that do not happen in the case of switching. Now the problem what occurs here is the switch start learning the MAC address, which is very frequent now. Okay, the learning of MAC address is very frequent because of the frame which is going in and out. Now what happens is these devices, these boxes, let's say it's a 2950 series of switch, they all come with some sorts of MAC address capabilities. That means a switch can handle thousands of MAC address at a time. Now during the loop, this range gets uh, completely choked out. Now there could be 10,000s of MAC address which is getting learned at a single second, due to which the switches start showing alerts saying that MAC address incapabilities. And that is the exact issue which leads to slowness in the network. Okay, any computers which are connected behind the switches, any server which is behind the switch, and a user is trying to access, their packet is all looped. Due to the looping, slowness is increased. You get the troubleshooting ticket saying that the application is slow, or I'm not able to access the server. It's all because of looping. Okay, and that is why we make use of the spanning tree here. Okay, so that
And
was
we're
just
going to cover this in detail, guys. So you did not worry. We are not talking. This is just a
yeah.
short introduction about a switch.
Yeah, so
And it's
whatever we are going through is just the introduction. Okay, the actual class will begin. So don't be worried about
so that
the trainer.
it's
Yeah.
actually good, Sagar, right? They are very curious to know
Yeah,
that
that is
how.
good. But there are few students who are not in the Zoom. So I mean, who are not in the Zoom. So I just want to let the other student also know that this is just a demo class. The real class will have all these things. Okay. So yeah, Sangeeta madam, you just take it forward. Okay.
Yeah. Okay. So I guess if anyone has any more questions, people have given their quizzes, I feel. All of you are given? All of you have given, or only few of you have given? Because I find that people are cunning enough not to give the quiz. They just try to escape from the question, is it? Guys, just try to attempt. It's just going to check whether you know whatever you know. It's not going to give you any kind of punishment. Right? The way we used to have in our college days, that we used to have punishment or get less marks. So don't worry, guys. Okay, so I will be showing you the details of the routers in the tomorrow's class, because I guess now it's already time's up. Maybe many people will have a lot of other work, and other batches are also being scheduled. So generally the lecture schedule would be from 6:30 to 8 o'clock. And moreover, I will try to see that I wind up by 7:40, so that we can have a lot of discussions, lot of questions which we can take up. Okay.
Okay.
Glenn is interested to know, are we having this class during the Xmas? We'll take a call on that once we start the full-fledged class from Monday. Right? Right,
Yeah.
Glenn? Okay. So I hope most of you have enrolled for the course. Yes or no, guys? Tell me quickly. How about the enrollment process? Is it done?
How much is the tuition for this course?
I guess Sagar would help out personally. You have to call up. You can take down his number and just try to message him and get the details.
Okay.
More or less, you know what you're going to get from the course, right? You have a lot of things coming up in the course.
I know.
Yeah. If anyone has any question, we can talk about. Sagar has already mentioned it in the chat as well. CCNA plus ASA, both modules, 4-month lab access, web workbook, the class notes, the web portal work.
Well, I think I'm writing my CCNA in January 12th.
Okay.
So,
okay.
I would not say I'm a starter, so I know much about. I've had the training in my country where I come from, that is in Ghana, Africa, before I came to the US, but I never sat for the exams. Now that I want to use it professionally, so I'm going to write it.
Okay.
Yeah. So.
Okay, so we'll meet up tomorrow with the router and I'll show you some configurations on the packet tracer as well. Okay, some kind of commands, how to run the commands, and yes, specifically what Kapil sir asked me about, how do we go ahead with the configuration if I get a switch, how should I take my computer and a cable and connect and start my configuration. So those things will work out tomorrow. Okay guys, is it cool?
Yeah.
So thank you so much. Bye-bye. Have a nice day.
Bye.